Please go to elithecomputerguy.com and failednormal.com to see the videos that are too dangerous for YouTube. Welcome back. So in this video, we're going to have yet another project for all ages. Whether you're 5 or 55, everybody likes to play with autonomous vehicles. Vroom, 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 vroom. So today's autonomous vehicle that we're going to be creating is a line-following autonomous vehicle. So this little vehicle, what we're going to do is we're going to put a line on the ground. We're going to have it do some turns and such, and this vehicle will then follow the line. So that's how it's going to be moving. Now, what's cool about this is we're going to be using the infrared proximity sensors that we've used in other projects, but in this project, it's not going to be for avoiding obstacles, but we're actually going to be using these sensors in order to follow the line. The way we're able to do that is an interesting property with infrared and wavelength and electrical tape. Curiously enough, black electrical tape basically completely absorbs the infrared spectrum. So what we're going to do here, basically how we're going to write the code, is what we're going to say is when the sensors detect an object in front of them, but how we've positioned these sensors, they're now pointed downwards. So basically, when these detect something under them, we're going to have the wheels move forward. When it does not detect anything below it, because it's going to go over the tape, and the tape is going to absorb all of that wavelength. When it doesn't detect anything, we're then going to code it so that it turns, so that both of the sensors now do start detecting something. So the idea being is the vehicle is going to go along. Whenever it goes over the electrical tape, it will then sense that basically there is no longer an object in front of it because this is absorbing the infrared wavelength, and so then it will turn until it now detects that there's something below it on both sensors, and then it will go forward. So that's how we're going to make this vehicle be autonomous and follow lines. This is also an important thing to be thinking about when you're thinking about sensors, using sensors in projects, and dare I say, hacking sensors, right? Because whenever you look at a sensor, you have an idea of how the sensor works. Again, with an infrared proximity sensor, you're thinking, okay, when it gets close to an object, it will detect that there's an object there, and then I'll code for it to do something. But one of the things that you really need to be thinking about is what about material, colors, different types of objects that the sensor will not detect like they detect 99% of all objects. This is one of the things that can be very dangerous with autonomous vehicles, where for some reason, let's say the material, for some reason the wavelength of whatever you're sending out, the material reflects it in a different way, or maybe because of the color, the wavelength is absorbed. This is one of the ways where you can have something go in front of a vehicle. The vehicle should stop. All the sensors are there, but for some reason the sensors don't detect the object in front of it, and then somebody gets rolled over. So this is one of those things that you should be thinking about from a design perspective, and also frankly a hacking and security perspective, thinking about the ways sensors don't necessarily always act in the way that you would think they should act. So with that, let's go over to the workbench so I can show you the components that are required in order to create this line-following vehicle. And then I will show you the code, then we'll put it all together and actually put it on the floor and show you how this thing drives. So here are the significant components of this particular project. We're using the Arduino Uno board like we normally do. Again, generally you can use almost any Arduino board that you would want to. Then what we're using these standard infrared obstacle avoidance sensors. So basically we're going to be using 2 of these, one for the left, one for the right. Then past that, we've got a battery pack. So again, being an autonomous vehicle, we have to have this thing untethered so it can drive on its own. So we have the battery pack here. We have the little micro breadboard. So the micro breadboard is going to be used in order to connect all the power connections, because we're going to have a lot of power connections. We have to connect the wheels to power, the motors to power. We have to connect the infrared sensors to power, so on and so forth. So we're going to be using this to be able to join all those connections. And then we're going to be using my little favorite FeeTech vehicle platform. So this is the vehicle platform I use for a lot of my projects. Again, it's very inexpensive. For $17 to $20, you get the whole platform, you get the motors, you get the controller, so on and so forth. The thing that I like about this is you get this little 2-channel motor controller here. Very nice, very small, very easy to work with. And basically, the main thing to understand from a programming standpoint when you're doing your sketch is this makes the motors seem to be continuous servo motors as far as the Arduino board is concerned. So whenever you're dealing with motors, you can use a motor module in order to control the motors, you can use a motor shield to control the motors, or you can use a continuous servo motor in order to control the motors. And so for this code, we're going to be using a continuous servo motor. So basically, these are the things that we're going to be using to build the project, and when we get the project built, it's going to look like this. Isn't it so pretty? Okay, it's not so pretty. You probably, if you do this, you probably want to do a little wire management. Now, the one thing on here that is significant that I didn't show in the components is you probably are going to have to build some kind of little mounting system for these infrared sensors. So for this project, again, the infrared sensors have to be pointed towards the ground. And so, you know, when you have the normal vehicle thing, normally the sensors point outward. It doesn't really have anywhere on here to secure sensors to point towards the ground. So for this, literally all I did is I went to Home Depot, I got a piece of aluminum, I hacksawed the piece of aluminum off at whatever this is, 6, 7, 8 inches. I drilled a couple of holes in it. I bent it at 90-degree angles here, screwed it all down, and that's how I created it. So, but to understand, I mean, literally, if you want to just tape these, I mean, you could tape these to the frame. You know, depends on how permanent you want to make this particular thing. I just did this again because I'm going to be using it for a lot of projects. But otherwise, so that's what we got. So we have the 2 infrared sensors, and again, they are pointed towards the ground. So when you have them pointed towards the ground, one of the important things is they should not touch the ground. Don't want them to touch the ground because then they're going to be scraping across the ground. And if they're too close to the ground, then you may get some weird readings from them. So with me, I have them, I don't know, maybe 2 or 3 millimeters above the ground here. And I have that on both sides. So they're both. So that's the thing, is you don't want them touching the ground. You also don't want them too far away from the ground. You just want a nice little space in there. Again, I don't know, 3 millimeters or so should be good for you. Then we have all this. We have the Arduino board, obviously screwed up to the top here, and then we have the control board at the bottom. So basically, we have the control board, the control pins for the control board come up here, and so these are going to be pins 10 and 11. So 10 is going to control the left wheel, 11 is going to control the right wheel. As far as the infrared sensors are concerned, we have pin at number 8. Is going to be the input for the left infrared sensor, and pin at number 9 is going to be the input for the right infrared sensor. And then here, where we use the micro breadboard, this is where we have to divvy out all the power. So we're going to use one connection to ground for the negative, for the ground line on this the breadboard, and then we have one connection to 5-volt power, and that's going to be for the power. So the 5-volt is going to power both sensors and both motors. The ground is going to be the ground for both sensors and both motors, and so that's why you need a little micro breadboard like this to make your life easier. And so with that, this is basically what this thing looks like once it gets built. The only additional thing is then you take your nice little USB battery pack, you shove the battery underneath, you plug it in, and away it goes. It'll be autonomous. So with that, let's go over and take a look at the code, upload the code, and have this thing go for a drive. So here's the code that we're going to be using for our little line following vehicle here. Now the first thing that we have to do is we have to include the servo library. Again, that little motor controller that we're using, that makes the motors seem as if they're continuous servo motors to the Arduino board. In order to interact with continuous servo motors, we have to add the servo library. So we do pound include, and then we do servo.h, that includes the library. The next thing that we have to do is we have to define the pins that the infrared sensors are going to be connected connected to. So pound defined, left IR goes to digital pin 8, pound defined, right IR goes to digital pin 9. So that just tells the Arduino where the IR sensors are. The next thing that we're going to have to do is the motors are considered servos. So then we have to create those servos so that we can interact with them. So we're going to do servo, and then we're going to create one servo called left wheel, and then another servo called right wheel. So this is how we're going to be able to control those wheels separately. Then finally, for this part of the sketch, what we're going to have to do is we're going to have to create two variables, and these are the variables we are going to test against in our if, else statements. So basically, if this is high and this is high, do this. If this is high and this is low, do something else. So we need variables to test against, and so that's why we're creating these two variables here. So int, an integer, a whole number. Basically for this, it's going to be either 0 or 1. We're going to do left reading, so that's going to correspond to the left infrared sensor. Int right reading, that will correspond to the right infrared sensor. So this is how we're actually going to test for the left and the right sensors. Then we're going to go down here and we're going to create the environment. So we're going to use the pin mode function. Left IR, we're going to set to input since it's a digital pin. Pin mode right IR, we also set to input since it's a digital pin and it's a sensor. So we're actually detecting information. The next thing that we have to do is we have to attach the wheels again. Since these are servos, we actually have to attach them to pins on the Arduino board, so the Arduino board knows where to send commands. So left wheel dot attach, we're going to attach that to digital pin 10. Right wheel dot attach, we're going to attach that to digital pin 11. The final thing we're going to do here is we're going to start the serial monitor. Now, many times when I create autonomous vehicles, I don't start the serial monitor, but for this, I want to make sure all the two sensors are doing what they're supposed to do. They're actually detecting what they're supposed to detect, and so I'm going to start the serial monitor and output to the serial monitor just to verify. So if I'm sitting there and I'm trying to troubleshoot and I'm trying to figure out why the wheels are doing what the wheels are doing, it's important to understand what the sensors are seeing. Maybe the problem is the sensors aren't reading the way that you think the sensors should. And so that's why we're starting the serial monitor here. And then we come down and we do the loop. So the first thing that we're going to need is the left and right reading. So we can test against the left and right reading, basically the readings for the sensors. So what we're going to do is we're going to set the value of the variable left reading to digital read function left IR. So this is going to digital read from the left IR, and then it's going to set the value of left reading to that. Same is true with right reading. Then what we're going to do here, again for that troubleshooting procedure if we need it, is serial.println left reading, serial.println right reading. So what this will do is this will print out what the left and the right reading are so that we can verify that the sensors are seeing what they're supposed to see if we run into problems and need to do any troubleshooting. Now if we go down here, basically we're going to go down to the else statement. So this is where the actual brain power of this particular sketch comes from. So what we're going to say here is if left reading equals, so two double equal signs means equals low, and right reading equals low, then left wheel dot right 87, right wheel dot right 87. So what this means is using a continuous servo motor, 0 to 89 is forward, 90 is stopped, 91 to 180 is backwards, how I have this set up. So what I'm saying here is I want this essentially to go forward very slowly. So the farther you get away from 90, the faster the vehicle will move. So if I set this to left wheel dot right 10, then the vehicle would move very quickly forward. I've set this to 87, so only 3 away from 90. Why? Because I want it to go forward very, very, very slowly. One of the big problems you run into with autonomous vehicles is if you have them drive too fast, many times they go too fast for the sensors to be able to compute what's going on, and that's when you'll start to run into problems where basically the vehicle literally is physically moving too fast for the sensors to be able to determine what its environment is, and then it overshoots the mark or you run into problems. So especially a project like this, I would rather it go slow and be accurate than be fast and cause all kinds of problems. So this is going to be left reading equals low, right reading equals low. So when the infrared sensor detects something, so when it detects something, that is a low reading from it. And so a low reading is 0. So if it's getting a low reading, it's detecting something right in front of it, I want it to go forward. Else if left reading equals high and right reading equals low. So what this means is the left sensor now no longer detects anything. It doesn't detect anything because it is over the electrical tape, and so that electrical tape is absorbing the infrared wavelength. And so basically, as far as a sensor is concerned, it's looking into the abyss. So the left side is looking into the abyss. The right side equals low. So you have the and here, right? So left reading equals looking into the abyss, and right reading, is right close to ground. At that point, what I want to have happen is I want the left wheel dot right to 90. What this does is it stops the left reel. Stop left reel. Right wheel dot right 87. So this keeps the right wheel going forward a little bit. And so basically what this is going to do with the right wheel going forward and the left wheel stopped, this is then going to turn the vehicle left, and so then that should put it in a better position and it should be able to go forward again. Else if left reading equals low, so left reading detects the floor below it, and so again, a double and sign, and right reading equals high. So now the right side, the right sensor is looking into the abyss because it is now over the electrical tape. And then what I want to have happen is I want the left wheel dot right, I want it to go forward very slowly at 87, and I want the right wheel dot right to stop at 90 so that it can then turn right, and again, right itself, so it continues following the little track. Else, basically, if it's not both low, if it's not one high, one low, if it's not one low, one high, so basically if it's both high, so this is when if both sensors are over the electrical tape, both sensors no longer detect something right below them, then I want both the left wheel and the right wheel to stop. So that's where we're gonna have a little finish line here, and that's where it will stop and won't go forward. And then I delay for 10 milliseconds. So this is an important thing to be thinking about when you do a project like this, when you do an autonomous vehicle and it's looping. How long are you going to delay it for? Remember, all this if, else statements, all the variable, all this only happens when the loop runs. So if you delay the loop by a second or 5 seconds, it's literally going to keep doing whatever the last command was for that length of time before the loop runs again. And again, with autonomous vehicles, you can run into some difficulty that way. So with this, I'm literally delaying it for 10 milliseconds. So we're delaying it for like, what is it, 1/100th of a second. Just delay it just a little bit, just give it a little time, but then it should keep going fast. Again, this is one thing you're gonna have to look at with autonomous vehicles. Do you delay it for 100 milliseconds? Do you delay it for 50 milliseconds? Do you delay it for 500 milliseconds? Go and play, and basically you can figure out what is the best for this particular vehicle. So with that, what we're going to do is we're going to upload the code, and then we're going to go over to my little demonstration area, and we're going to have this vehicle drive around. Okay, so I've uploaded the code to the little vehicle, and I've put a line of electrical tape on the floor here. So you can see this is a nice thick line of electrical tape. So basically what I did is I took two pieces of electrical tape and put it side by side. So that gives us about 1.5 inch line, 1.25 inch line. So that's a nice big line for the vehicle to be able to follow. And then at the end here, I put a nice big black spot. And so the idea being is when both sensors look into the abyss, that the vehicle should stop. So it should go around, go left, right, left, right, left, right, all the way here until it stops. So with that, all you do is you take your vehicle, you take your nice little battery pack, plug it in here, and then we're going to put it down, and hopefully the vehicle will be able to follow the line. So there we go. It's following the line. So the right detects. So see it's turning, it's turning, it's turning. Then the left detects. It's turning, it's turning, it's turning. Turning, 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 turning. Then the right detects, turning, 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 turning. That should detect right again, turn, turn, turn. There we go, doing pretty good there. Then one more, turns again to the right. And then comes into the straightaway, goes over the thing, and now it hit the finish line. Both sensors detect, and therefore it stopped. So that's basically how this project works. Again, what you'll notice is I have had the vehicle running very slowly, and you can see as it's following the line, if it went too quickly, it might overshoot the line and then just keep going off into the distance. So that's one thing that you have to be thinking about, is thinking about the speed the vehicle will run to make sure it doesn't overshoot something like the line or whatever the sensor is supposed to detect. But there you go. That's basically how this works. So, vroom, 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 vroom. We have built another autonomous vehicle. So this is a line following autonomous vehicle. And the idea is it simply follows the line on the floor that you've created using electrical tape. And so again, this is an interesting way that you can use sensors in a way that you may not have initially thought of. Again, you may think of infrared sensors basically just for that obstacle avoidance. And this shows you how you can use them to actually follow lines on the ground. Now, again, it is important as you play with this, again, to go in and play with things such as, the speed of the motors, how fast you want the motors to go, what the delay should be, so on and so forth. Because the faster you make the motors, it may go faster, but then if it overshoots lines, right? If it overshoots lines, then you're gonna run into other problems. So this is the kind of thing to be thinking about and try to figure out, what should these settings be, go in there, tweak them, and play with them. Again, simple things like, yes, this vehicle will follow a single width of electrical tape, but if it's only a single width, there's more chance that it will drive over the tape and keep on going. So things such as, okay, we're gonna use electrical tape, but let's use 2 widths of electrical tape just to give it an extra safety measure to make sure it's more likely to detect the tape and it won't run off into the distance. So this is a fun little project to play with, and definitely I think it's a cool thing. Again, with this type of thing, this is the type of deal where you could add additional sensors to it, so you can have a line following robot, but then actually put proximity sensors in the front of it, so you can have it follow a line, and then if there's an object in front of it, you can have it stop. And when the object moves, then it can keep going on. Those are the additional types of things that you can add to this project and start playing and start having this idea of, okay, I'm creating a vehicle with multiple different types of sensor inputs, and how do I want those if, else, if statements to work out? What sensors take priority, that type of thing. So that's all there is to it. As always, I enjoyed doing this video and look forward to seeing you at the next one.